In this video, we're going to go over Z-Wave door locks and adding garage door control into Elan. Z-Wave door locks is actually extremely easy in Elan. In our previous video, we showed how to add the Z-Wave network within Elan, how to enroll our devices, whether that be a door lock, whether it be a light switch, whether it be a thermostat. It doesn't matter what you add into the Z-Wave network, then it automatically will throw it into the subsystem category that it belongs in. So door locks will populate automatically in security, like these four have here. Climate, thermostats will automatically populate there. Z-Wave dimmers or light switches will automatically populate in the lighting tab. So once the Z-Wave network is added and the door locks are enrolled within the Z-Wave network, these are nothing more than placeholders. There's more configuration that's done where assigning users, assigning PIN codes, and that's explained in a different video, and it's all done through the viewer. It's customer facing through the touch panels or the viewer themselves. What we're going to focus on here is the garage door control. There's a couple options here based on the application. We've got our smart garage door openers, the MyQ or the Chamberlain. We've got our traditional garage door openers that would just require a pulse simulating a button press on the actual opener itself. And then we've got some Z-Wave modules that integrate, and we're going to go over a couple different scenarios here. So we're going to go to door controls, we're going to add new device. First here, this window pops up, we've got name. Basically, you're just assigning the display name, whether that be big garage, small garage, side garage. This is end user facing what the door is called. And then we've got our type. And the couple that we're going to focus on here today are lighting and security zone output toggle. We're going to start with lighting. So when we add that as a lighting type, some of our Z-Wave garage door modules, specifically the Go Control GZ series, will populate into Elan as a light switch. And what's nice about that is basically thinking the garage door is a light switch. When the light switch is on, the garage door is open. When the light switch is off, the garage door is closed. And it tracks status that way as well. So with the GZ Go Control piece, it's going to come in as a lighting device. We've added this. And this drop down here, we would navigate to the actual lighting device and select it. Once we've done that, then we've got input logic. And basically, if you see that it's reversed, if you see that on our status feedback on the touch panel, if it says the garage door is closed, but it's really open, we just need to reverse that input logic so it tracks the status correctly. So that's how we're importing it through a lighting system. Now the next one I want to go over is security zone output toggle. Now this is nice, especially if you're going into a house that already has a security system built into it, right? We can pull from that, especially if we're integrating with that security panel, like our 2 gig edge. So we'll set that and we'll hit OK. Now we've got some options here that look a little bit different. We've got input logic and output logic. And basically input logic. How are we tracking status on this? Well, since we already have a security system in it, I'm going to go ahead and I'm going to select that specific garage door on that security zone. So now we've defined how we're going to track whether the door is open or closed. The next thing down is our output logic. Now, if we are triggering this using the relay outputs of our controller, whether it be a 300, a 100, or an IO200, we're defining it here. So basically what we've done here is we've defined our input logic. It's going to look for the security panel. When that zone's faulted, that's how we're going to pull status on it. Our output logic, meaning our control logic, it's coming out of our relay contact closures, and we've defined it, this one specifically coming from an IO200 output 1. And then the last, we've got our input logic, just like we did when we added it as a lighting device. If it's reversed, then we would flip this to reverse and not normal.